glitches in opengl shadowing. So that we saw, means if I kind of don't consider the texture based shadowing also, then still means we have to know the pixel density, screen size, then all the transformation matrices, and then matrix multiplication. Still means anyway matrix fundamentals that anyway we need to know, but this much information is required. Now if I go for texture based shadowing, then texel density, pixel texel density relationship, so that information is required. Now beyond that, if I go for texture kind of shadowing, then as we saw that means frustum kind of knowledge is required. And then if we come inside the texture, then texture object and texture object creation and what attributes it required, what functionality it provides, frame buffer, and then finally texture unit. So how texture unit does the sampling of the texture, and then it returns the texel color based upon the texture object property. So that we saw. Means as kind of repeatedly I am saying, like opengl is very easy if you understand step by step. Otherwise it is completely kind of uncrackable, opaque substance. So means you will land up mucking your hand here or there, and you will spoil weeks, not days. So that is the concept. I mean for any complex programming step by step knowledge is required, but I mean I am thankful to kind of Python kind of languages where you don't carry any headache for matrix multiplication or any kind of you do the computation, everything is available. Means you can do kind of you can save 10 times line of code that you do with other programming languages. You don't worry about polymorphism, you don't worry about data typing, and don't ever worry about kind of many functionality like file handling and those kind of things. So anyway, so far so good. I hope that no more glitches come. So whatever glitches we saw in the texture mapping is kind of shadow acne. So that we nicely we removed when we understood the texel pixel density relationship. So that would come in texture filtering. So what we do in mag and min filtering, so there we kind of hit. So that comes under great shadow acne. But if we see the repetition and clamping of the texture shadow, I mean if texture is texture what we generate in the first pass is smaller to the actual screen, then it may go for the shadow acne, it may go for a clamping or a repetition. So we saw that if texture image is smaller, considerably smaller to the screen size, then we did not do our kind of a smart mathematics if computation is happening outside the texture. So all the mathematics we do only inside the texture. So beyond that we consider that length is 1, means it is infinite distance behind the scene. So we don't do any shadowing at all, and this is how we kind of control it. So that is the scenario. So we kind of bind up the texture shadowing glitches, and let's hope that nothing should come up, and then we will have kind of bright videos, and I am very hopeful to kind of implementing social media or social kind of 3D graphics, and that would kind of incorporate machine learning stuff also, like automatic 2D to 3D graphics what we see, and then automatic automation, so those kind of thing, so that will include. So that's what we'll see.